Hi, welcome to my video on relations in terms of x and y. The ordered pair xy expresses y in relation to x. The independent variable is x. The dependent variable in this ordered pair is y. The values of y depend on the values of x. A linear relation is a line. The degree of the line is 1. The highest exponent is 1. If you look at y equals mx plus b, then that's a 1 and that's a 1. So the degree is 1, the highest exponent is 1, is a linear. Let's look at linear equations using the set notation. A, this is the set of all x and y such that y equals x, where x belongs or is a member of the natural numbers. And the natural numbers are 1, 2, 3, 4, and dots continuing on. The independent variables are the values of x. So the independent values are the set of natural numbers, which is 1, 2, 3, 4, etc. The dependent variables, well, let's look at the graph and see if this is x and y in a table of values. Let's select some values of x, 1, 0, and negative 1. Remember, we can't write down all the natural numbers in the table, so we just pick some of them. Y equals x, so y is 1, 0, and negative 1, because y and x are equal. So let's graph 1, 1. X is 1, y is 1. X is 0, y is 0. X is negative 1, y is negative 1. So we're graphing. So we have the set of integers, the set of natural numbers. So notice I'm putting dots there, but I can't draw a line through these dots because that would mean I'm using a half, or I'm going to use 1 1/2, or I'm going to use any decimal or fractional form. So I can't connect these dots up, but I can keep on going with these dots like this, and I just put an arrow on the end of that dot to show that it's moving on, and an arrow down here to show that it's moving on. But they're dots, so I can only connect with dots here because I got integers. The natural numbers. B, the set of all x and y such that y equals 2x plus 1, where x belongs to the integers. And we know the integers are 1, 2, 3, dot, 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 and 0, and they're negatives. Negative 1, negative 2, negative 3, dot, dot, dot. So that's the set of integers. I stands for integers. And the independent variables in this case is the values of x, so that's the set of integers. So let's look at what happens in the table. We got an x and a y, and again, you can't graph all the integers, so we'll just use a 1, 0, negative 1. So if I take the equation and write down y equals 2x plus 1, then I'm going to fill in 1 for x. So that gives me 2 plus 1 is 3. I'm going to fill in 0 for x. So that gives me 0 plus 1 is 1. And I'm going to fill in a negative 1 for x. And that gives me negative 2 plus 1 is negative 1. So again, integers are going to be, when we graph, it's going to be a set of dots. Discrete, as we say, it's discrete. The dots are discrete, not continuous. So, I forgot to label some axes here. Just put these in on this graph. So, let's see, that's a 2 and that's a Okay, here we go. That's an X and a Y. Sorry about that. So now we got a graph 1, 3. X is 1, Y is 3. X is 0, Y is 1. X is 0 right there, Y is 1. And X is negative 1, Y is negative 1. X is negative 1, Y is negative 1. So again, there are a set of dots. If you want to keep on going, again, we have a slope of 2 and a y-intercept of 1. So if you think about it, I got a y-intercept of 1, which is right here. Slope is 2 over 1, so I go up 2, right 1, up 2, right 1, another dot. And I can go down 1, left 2, and I down 2, left 1, sorry. I get another dot. So this is a set of dots that represents, I can't connect these up. And that means that if I use all the integers, that means the dependent variable is y, so y belongs to the integers. C. Now we have a set of all x and y is equal to 2x, where x is less than or equal to, 0 is less than or equal to x is less than 3, and x belongs to the whole numbers, w for whole numbers. Notice here we have 0 is less than or equal to x less than 3. That means 0 is included, but 3 is not included. So we have the set of whole numbers. 0 is one of the whole numbers. In between that we have a 1, and we have a 2, and we can't put a 3 here because 3 is not included in this set, even though 3 is a whole number, but we can't put it in. So that means we can graph x and y. We have a 0, a 1, and a 2. If we take the equation y equals 2x and we put 0 in, we get a 0. If we put 1 in, 2 times 1 is 2. If we put a 2 in place of x, we get a 4. So when we got the whole numbers. The whole numbers, when we graph, is a set of dots. It's discrete. And 0, I put a 2 and a 2 and a negative 2. Sorry about that. I should have made sure that this was filled out okay. 0, 0 is right there, the origin. 1, 2. X is 1, y is 2 is there. 2, 4. X is 2, y is 4 is right there. Notice that's the only 3 dots, because it's whole numbers, that's the only 3 points that I can have on the graph. That means the range must be 0, 2, 4. The range, or sorry, I should say, the dependent variable is 0, 2, 4. When I said range, then that's coming up later as the same as dependent. And the independent variables are 0, 1, 2. And we notice now I have the same x, y equals 2x, 0 less than x equal to x less than 3. But I have, notice, exactly the same, except belonging to the whole numbers. This is belonging to the real numbers. So I still have to use some numbers, so I will use starting off at 0. I will start using at, again, 0 starts it, then I can use a 1 and a 2, and 1, 2. I can use can't use a 3, but I have to put the 3 here because the real numbers, I'm using all the values between 0 and 3, but not 3. So 0 starts this when I shade in, and 3 ends it. But 3, I put 3 here, but really your independent variable is, that's any greater than, I have to write all this down for the independent variable. And what comes out is based on what we have in the y equals 2x. So we put a 0 in, we get the same values as here, 0, put a 1 in, we get a 2, put a 2 in, we get a 4. We have to put the 3 in to get a 6. And because, again, this is real numbers are shading in between, so I have to start at 0 and end at 3 for x. So the y values are, they start at 0 and they end at 6. Those are the values of y, and y belongs to the reals. And the only difference is that I shade in everything as before dots. You always have the graph here in terms of using your dots. 3 gives you 6. But when you get your individual points done, because this is reals, you have to shade in all the points on this line. Because it's real numbers, you have to do a shading. You have to do an official shaded line. So this is all the real numbers, but I have an error. So what happens? I can't use that up there, and I can't use this down here. Even though I drew my line, I made a mistake and extended it further, because I can only use the values of y, these values of x, and these are the y values from 0 up to 6. That's a 6, that's a 2, and that's a 4. So I can only use this segment or part of the line from there to there. I can't continue on. So I can't go down there, or I can't go up here. I can only go from here to here. And this dot right here is hollow because the 3 is not included. This dot is not included in this interval, whereas the 0, 0 is, because 0 is allowed to be used, but 3 is not. So that's a hollow dot saying it's not included. That's a solid dot saying it is included. Okay, practice means pause your video and to see if you can graph these and work out these answers. Here we go. The set of all x and y says that y equals negative x plus 3, where x belongs to the reals. So we have the set of independent variables, we have the real numbers. So when we graph, this is x and y, the table of values, we can use any values of x. So I'm going to use a 1, 0, negative 1. And the equation is y equals negative x plus 3. So I'm going to use a 1 in the place of x. So that gives me negative 1 plus 3 is 2. Now I'm going to put a 0 in. Plus 3, 0 plus 3 is 3. And now I'm going to put a negative 1 in. And a negative 1, subtract 1. The negative of a negative 1 is 1. 1 plus 3 is 4. And that's some of that's graph those. Now remember, I got a graph using some points. So 1 gives me a 2 again. Forgot to put these numbers in. Here we go. So 1 gives me a 2. 0 gives me a 3. And a negative 1 gives me a 4. X is negative 1, 4. And because it's real numbers, I have to shade. Use a ruler, draw the line to make sure I'm going to draw it okay. There we go. Because it's real numbers, then I can draw a line. If it was whole numbers, if it was integers or natural numbers, I would have to use dots. But this is continuous. I'm using all. So that means my dependent variables are also the y values, which are reals, because it's shading in along this line. And another one to do, pause the video and work this one out. A set of all x and y such that y equals 3, where negative 2 is less than or equal to x, less than or equal to 1, and we have the set of integers. Notice it's equal to negative 2. Equal to, that means these are included. So the independent variables are integers. So I have to use a -2. I have to use a -1. I have to use a 0. These are the only 4 integers that I can use that fits this integers. And this is x and this is y. And I'm going to use these numbers here. And I have a y equals 3. So y is 3. So y is 3 for every one of these x values. So y equals 3. I could put down y equals 3 or just 3. I don't have to put, remember, the dependent variables are values of y. The independent variables are values of x. So we know these are all the x values and these are the y values. So I can rub out that and put just 3 there instead of saying y equals 3. Just 3 alone. And if you wanted to draw a graph of that, you can. You know, if you draw a grid quickly, you can go, that's x and that's y, that's 1, 2, 3, 4, 1, 2. And x is -2, which is here, y is 3, 1, 2, 3. X is -1, y is 3. X is 0, y is 3. X is 1, y is 3. So I have these 4 dots. That's the only, notice that the x is -2, -1, 0, 1, and y is always 3. 4 dots. So the graph consists of dots because it's integers. Number 3, we have x equals 2. So again, the independent variable is x, the dependent variable is y. So the only value of x I'm allowed to use is 2. And the y values are reals. So the y value is reals. If that be the case, that's x and that's y. X is always 2. 2, 2, 2. But the y can be any number, so let's pick some. 1, 0, -1 are some of them. Let's do it. The graph. We have an x and we have a y. And we have 1, 2, that's x's. This is the y's. X's and y's. There we go. X is 2, y is 1. X is 2, y is 1. X is 2, y is 0. X is 2, y is 0. X is 2, y is -1. X is 2, y is -1. But because these are reals, then I have to include all the values of y. I have to shade in. So these 3 points here are used to establish the line. Then I have to shade them in because I have reals. Now, number 4, write an equation of the line through the point 2, 1 and 3, 2. To get an equation of a line, I'm going to use the line y equals mx plus b. I could use a point slope form. Okay, let's get the slope. Let's call this one x1, y1, x2, y2. So the slope formula is y2 minus y1 over x2 minus x1. x2 is 2. Sorry, y2 is 2. y1 is 1. x2 is 3. x1 is 2. So there's 1 on the top, 1 on the bottom. So the slope is 1. Now I need to get the y-intercept. So if I write down the equation, y equals mx plus b, and I fill in, I'm going to use the point 2, 1, and I'm going to use the slope of 1 to fill in this equation. When I do, that's the x and that's the y. So y is 1, m is 1, x is 2. So when I fill those 3 variables in, the only unknown I have is my b, which is my y-intercept. Leave my b there. And that 2 comes over, moves over to the left, become a negative, so there's -1. So the equation is y equals mx plus b. The slope is 1x minus 1. Or we could go y equals x minus 1. That's the equation that represents this line in slope y-intercept form. And so that'd be the case. Let's graph it using the integers. And again, the integers are -3, -2, -1, 0, 1, 2, etc. on each side, dot, dot, dot. So the independent variable we're going to use is a set of integers. Okay, let's pick some integers. So let's pick a 1, 0, -1. And if we take the equation y equals x minus 1, we plug a 1 in. So we plug a 1 in the place of x, we get a 0. And let's put a 0 in the place of x, and we get a -1. And we put a -1 in the place of x, we get a -2. So that gives us these 3 points. So 0, x is 1, y is 0, x is 1, y is 0, x is 0, y is -1, x is 0, y is -1, that's the other point, and x is -1, y is -2, x is -1, y is -2, so we have these 3 points, but we're graphing over the integers, so the integers means dots, discrete, so we have to continue on with this line using dots. We're only allowed to use dots. So I put an arrowhead on the end of that one, and an arrowhead on the end. If I want to use more, put an arrowhead to indicate that they're going on, but they're only dots. And that means if I got only dots, my dependent variable is y belongs to the integers also, because I'm using all the integers. Okay, let's continue. What about if we graph this same one over the integers? Remember, we had the 2 points, which was these two, and we came up with the equation y equals x minus 1. So we want to graph the same equation going through these 2 points. So the 2 points are 2, 1, and 3, 2. So there's the 2 points that you're going through. But we want to graph it. Let's see. Why don't we, instead of using the table of values, say that the y-intercept is, or y-intercept is -1, which we could put right here. And the slope is 1 over 1. The slope is 1, but 1 over 1, so we go up 1, right 1, up 1, right 1, up 1, right 1. We can continue on. Or if we want, we can graph it, but y-intercept is -1, which is what we just did, and we did the slope. So we graph the 2 points. If I graph the 2 points, I can go down 1, left 1, down 1, right 1 from these points to get it. So many ways to graph this. Remember, just then I graphed it with a table of values. Now I did it a little bit different. And since it's real numbers, the real numbers have to be, you have to do the shading, joining up all these points. So there's a set of real numbers, and they go on and on and on. So the independent variable is x belongs to the reals, and the dependent variable is y belongs to the reals. Notice as this line goes this way, the values of x are going on this way. As the values of x go this way, notice the values of x are down here. If I extend the line, if I go up, say, the values of x go up and touch the line. As the line goes this way, the values of x are here. So you're covering really all the values of x on this line go down to the axis and you touch them. The values of y, you go sideways. If this value of y is here, this value of y is here. So as you go up, you're taking care of all the y values as you go up, and as you go down, the y values are right here, negatives. Go sideways, you get the y values. If you go up and down, you get the x values. X values are down there, touching the x-axis. The x values going towards the x-axis. So that leads us in graphing or doing a relation in terms of x and y. If you like my video, click the like button. Click the subscribe button if you're not a subscriber. Click the notification bell. More videos are coming your way. Write a comment on my video if you wish. www is my math website, Mathfully Explained. And the information on me is in this section. My degrees and teaching experience. My video section talks about the strategy you're going to use to help you learn your math. The content section has the videos, topics, and the number of videos on those topics. And they're on black font right now, and red font is what will be there in the near future. Thank you very much. Bye-bye.